In this video, I want to talk about some of the key properties of matter. So just a bit of review before we get started. Remember that matter is the stuff of the universe, what the universe is made of. It has mass and volume. That's how we define matter. And it can be classified as elements, compounds, or mixtures. Matter also has physical and chemical properties. Physical properties can be observed or measured without changing the substance itself, but chemical properties can only be observed during or just right after a chemical reaction. And so chemical properties require, or to be able to see chemical properties, we have to have a change in the substance. So physical properties can be further defined as intensive or extensive. Intensive properties are things that are inside or part of the substance, and so they're not affected by how much you have of that piece of matter. Color, for an example, is an intensive property. Gold is golden. No matter how much gold you have, it's still going to be that color. Extensive properties, on the other hand, are affected by the amount of matter being observed. And so the mass or volume of a substance will depend on how much you have. Most of the physical properties that we're going to be talking about are intensive. They are inside or part of that substance. So I'm going to go through several examples of physical properties, and then you'll be doing activities to help you drill these and remember them. Density is the first physical property I want to talk about, and it actually is a measure of how tightly packed the molecules are in a substance. We calculate it by taking the mass of the substance that we have and divide it by the volume it occupies. So something that has a really high mass and a very small volume is going to be very dense because it has lots of particles packed into that smaller volume. Hardness is another physical property, and that has to do with how hard something is, how easily it can be scratched. In the previous science classes, you may have talked about the Mohs hardness scale that's used to identify minerals. Well, in this case, this picture is showing quartz scratching calcite, so one mineral scratching another, and so that's another physical property. Luster is a measure of how shiny something is, and related to, or compounds that have luster also often have some degree of ductility or ductile. They are ductile, and that's, can you take that substance and turn it into a wire, pull it thin and stretch it into a wire. Things that have ductile, or that are ductile, that have ductility, are also likely to have malleability or are malleable, and that means you can take that substance and hammer it into a thin sheet. So many of our metals that we're familiar with are shiny, they have luster, we can turn them into wire, they have ductility, and they can also be pounded into thin sheets like this copper foil picture, and so that it has malleability. Things that are not metal are often brittle. So brittleness is another physical property, and that's a measure of how easily the substance breaks upon an impact. So we have a ceramic pot here that's broken into many pieces. Another physical property of liquids is the viscosity or fluidity, and that's a measure of how easily a substance pours or flows. And this one's kind of tricky because something that's very viscous actually does not pour very well. So honey is very viscous, whereas water is not. Electrical conductivity is another physical property, and that's a measure of how quickly or how easily that substance will conduct electricity. Then we have solubility, which is a measure of how easily a substance will dissolve in water or another solvent. So we have salt being dissolved in this picture. Another physical property is the melting or freezing point and the boiling or condensing points. These are the melting and freezing are the same temperature, but it depends on which direction you're coming from. So if a solid is turning into a liquid, say with water at 0 degrees Celsius, that's the melting point where ice will turn into liquid, but it's also the freezing point where liquid will turn into solid if you're getting colder. So this is the temperature at which the substance changes from solid to liquid or liquid to gas, or back the other way. And then there's a bunch of other physical properties that are sometimes talked about, things like magnetism or the transparency, how light goes through a substance, the specific heat, how much heat it can absorb, how much heat energy a substance can absorb before it changes temperature, the texture of the substance, the odor, does it have a smell or a taste even. But the list can be quite long. Then we get to chemical properties. Chemical properties, remember, are ones that we only can observe if there's a chemical reaction happening. And so they're more closely tied to the type of chemical reaction. So there's just a few I want to highlight. You'll learn more about that as we do chemical reactions in class. So the first one is combustibility, or how combustible something is. How does it react? How well does it react with oxygen to burn, to produce heat and light? So we've got the paraffin wax is very combustible. It burns very easily. Corrosion is another common chemical property, and this is the ability of a substance to be broken down by reacting with oxygen. We typically just call that rusting. So corrosion is the fancy scientific name for what we would call rusting, or rust actually is an oxide version of whatever the original compound is. So here we have a steel pipe, so the iron is turning into iron oxide. Toxicity is another chemical property, and that's the ability of a substance to damage living organisms or the tissues inside living organisms. And then we have how acid or base or alkaline, acidity and basicity are related to, again, something chemical, the ability to donate or accept hydrogen ions. We measure that, of course, with the pH scale, which will be something you will get to do. And then the final chemical property I want to mention is radioactivity, which is the ability of a substance to emit gamma waves, or to emit, that means to give off alpha or beta particles. In the process of giving off alpha or beta particles, the substance actually changes what it is. And again, this radioactivity is a chemical property. These are all examples of properties that only can be seen when something is happening. Technically, radioactivity is a nuclear property, but again, we do have a very definite change going on. So, speaking of changes, matter can experience physical change, but physical change only affects the form of the substance. It doesn't really change, it doesn't change what the structure is, what's in the molecules, how they are put together. So the intensive properties remain the same. Physical changes include things like a change in temperature, which leads to what we call a phase change or a change in state. And both of those phrases are used, and I can't guarantee I will consistently use one or the other. So just realize a phase change or a change in state when we're talking about a physical change going from a solid to a liquid to a gas to a solid. Those words are interchangeable. Physical changes also could be something like cutting or crushing or dissolving a substance. So dissolving something in water, making salt water, is not a chemical change. You're not having a chemical reaction by dissolving something. You can get that substance back. In case of salt water, we just evaporate off the water and we've got the salt again. Matter can also experience chemical change. And then again, because chemical changes are going to be chemical reactions, you're going to see changes in the molecular structure. Atoms are rearranged and new properties form after a chemical change. Most chemical changes are irreversible. A few you can reverse and go backwards, but most of them just only go in one direction. So this little diagram is showing you how we've got two elements that are separated on one side of the chemical reaction, and then they have been combined on the other side. When there's a chemical change happening, we have some evidence, and some of the key pieces of evidence that you look for to see, is a chemical reaction happening, is chemical change occurring, has the color changed, is there a different color now in front of you, or is there a smell, an odor? Now generally, if you've got a smell coming, you've guaranteed you've got a gas being produced, even if you don't see gas bubbles, because your nose is responding to particles of gas. You can't smell anything if there isn't a gas particle to be picked up by the receptors inside your nose. Another key evidence of chemical change is that light or heat energy is given off. And the glow sticks that I have over here as an illustration, there's a chemical reaction going on. Chemical change is happening inside those glow sticks in order to produce that light. And then finally, a new solid, or what's known as a precipitate, that's the scientific word for a solid, is another evidence of chemical change. And we've got a beautiful yellow solid, yellow precipitate being formed in this beaker. So how do we use properties? Well, the properties of a compound are not the same as the properties of the elements. And so, for an example, to take water, H2O, hydrogen, and oxygen. Well, hydrogen is a gas at room temperature and is highly explosive. You may be aware of the Hindenburg, the airship that exploded back before we had airplanes, or about at the same time we had airplanes, where they were using airships for travel, or blimps, what we call them now. And so hydrogen is not something that's very stable. It will easily explode. Oxygen is also a gas at room temperature. We're breathing it in, and it's very important to us. And oxygen will increase the rate of combustion. It increases fires. I mean, you're probably familiar with wanting to, if you are in fire, you stop, or if you personally are experiencing a fire in your clothing, you would stop, drop, and roll because you're trying to smother the fire. You're trying to cut off the oxygen. But water, which is a combination of hydrogen and oxygen, is actually a liquid at room temperature. So we've changed physical properties of the elements. From the elements to the compounds, they've changed from a gas to a liquid. And water, of course, is used to put out fires. So the chemical property of encouraging a fire of oxygen, or the fact that the burning very easily of hydrogen, is reversed because you can use water to smother a fire. So something that is a compound is going to have different properties than the elements that it's made out of. And then we use those properties to identify the substance. What is it that we have? What properties are there? Can we use that to figure out what this substance is? And we use properties to show that a chemical reaction has actually occurred. You'll be experiencing this in the lab and, of course, throughout the course as we do a number of chemical reactions, as we work on understanding how matter is used and changed in chemistry.